Well, ladies and gentlemen, after this session, we are going to quickly move on to our next session, which is about unfolding biases in e-commerce platforms, sponsored recommendations, buy box winners, and beyond. And to present this, we have with us Dr. Animesh Mukherjee, who is an associate professor and A.K. Singh Chair in the Department of Computer Science and Engineering, Indian Institute of Technology, Kharagpur. His main research interest centers around investigation of hate and abusive content on social media platforms, fairness and bias in information retrieval systems, media bias, and quality monitoring of Wikipedia articles. Some of the notable awards that he received are INAE Young Engineering Award, INSA Medal for Young Scientist, IBM Faculty Award, Facebook AI and Ethics Research Award, Google TensorFlow Award, GYTI Award, Humboldt Fellowship for Experienced Researchers. Ladies and gentlemen, presenting to all of you, Dr. Animesh Mukherjee. Over to you, sir.
Thank you very much for inviting me, and thanks a lot for the kind introduction. So let me try to share my screen. Should be visible.
Yes, it's visible, sir.
Okay, so as Fatima has already pointed out, that I'm going to talk a little bit about our work on biases in e-commerce marketplaces in this session. And this work is jointly done with a bunch of colleagues across India and abroad. So Abhigyan is a faculty at IIT Delhi, Shaptoshi is a faculty member with me in IIT Kharagpur, Krishna is currently the director of MPI SWS, and there are some fantastic students, PhD students, Abhishek and Siddharth, working with me on this problems. And along with that, we have some undergraduate students who have also taken interest and have come up and contributed significantly to this work. Okay. So I guess this is something that has become intertwined with our life and more so in this pandemic situation. So these days, most of the shopping are done on the online platforms. This could range from Amazon, Flipkart to Alibaba and many other such e-commerce platforms. And in this talk, I'll be using the terms marketplace and platform interchangeably. So let us take a closer look as to what an e-commerce marketplace look like. So basically, who are these stakeholders? So on one side, you have a bunch of sellers who showcase their products. On the other side, there are customers. And then there is a marketplace who is supposed to actually mediate between the customers and the sellers. And the sellers pay money to host their items on the platform, and in turn have an expectation to earn their livelihood, their products on the marketplace. So now this information access that the marketplace provides to its customers is through a bunch of algorithms. So this could be search algorithms, recommendation algorithms, various other selection algorithms. We will talk a little bit about some of these in the later slides. And there is a specific reason why we have drawn this box in black, because most of these are what they call black box. So it is not really known to the third party as to how these algorithms actually internally function. So it's not very clear to the third party as to how these algorithms are designed and on what data sets they work and how the predictions are usually made. So traditionally, if you look at IR research, it has been mostly keyed to relevance and customer satisfaction. So these were the two things that any information access system would try to achieve at the bare minimum. However, with the recent concerns around fairness, there has been a lot of studies which try to focus on fairness to customers, which is like equal satisfaction to all customers across different demographic, and then fairness to sellers by giving equal exposure to all the seller groups and their products that they showcase on the marketplace. However, one thing that has not been looked into in larger details is the platform itself, is the marketplace itself, like, and whether it has any role in this entire fairness research. So, and why is this important? So this is something that we need to really get into before like we can discuss about the studies that we have conducted. So why is the marketplace important? So one thing for sure is that the marketplace actually controls these opaque or black box algorithms. So it's hardly known like what are the different like functionalities, what are the different modules that set up these algorithms. So this is completely controlled by the marketplace. In addition, there are vertical integrations that the marketplace sometimes do with the which brings them in direct competition with the sellers. So this could be through something that is better known as private label products and special merchants. So these are merchants who have special relationship with the marketplace. We will talk about this with examples as we go forward. So basically, in addition to all the algorithmic machinery that the marketplace has control to, the marketplace also has vertical integrations in the form of private label products that it launches on its own platform, as well as connections to special merchants, like with whom they have like certain agreements. So, and like this is more important because the scale and sophistication is very difficult to, identify by the bare eye. So basically, it's very difficult for a customer to discern like what among the entire list of products or sellers that is being displayed on the marketplace, or what algorithms the marketplace is using in order to showcase these products. It's very difficult to discern those through bare eyes. And in fact, there has been a lot of concerns that have been raised in the popular press regarding various e-commerce platforms, and some of these paper cuttings are what I show here. It's not only limited to like the popular press, but it has also gone into the realm of policymakers, and there has been a lot of antitrust investigations. In fact, there are many ongoing ones like across the world. This include the US market, the European market, and as well as the Indian market, to name a few. So before I proceed to the kind of things that we have done, so this is kind of this disclaimer that I want to make at this point, is that our intention is not to target any individual or an institution as a whole. So it's basically what we want to show is our empirical findings, which are like statistically valid, and these observations we felt might have inadvertent consequences, and therefore we felt that this needs the attention of the larger research community, and that's why this work. So this is the first work that I'm going to talk about, so where we tried to do an audit, a systematic end-to-end audit of the sponsored recommendations on the Amazon e-commerce platform. And this paper was accepted in ACM Fact this year. So as I already said that there are different vertical integrations that the marketplace has, and one of them are these private label products. And it turns out that Amazon is no exception. So whenever Amazon, like when you land on the product page of an Amazon, so there are different types of recommendations that the page offers a customer. So some of these are called sponsored recommendations, which are actually marked by Amazon, so they are called sponsored products. And the other one is the general recommendations that which are actually emerging because of the viewership of the customer. So if some customer has viewed two items together, so one is related to the other by virtue of this viewership. So these are what we call the organic recommendations. So and then, as I said, there are different private label products like Amazon Basics, Amazon brand Solimo. These are the private label products that come directly from the house of Amazon, as well as there are third-party products like for instance, in battery category, you have Duracell, Panasonic, etc. And similarly, in the backpack category, you could have like Aristocrat and things like that. So this kind of shows that the marketplace itself is in direct competition with the third-party manufacturing brands. And the question now that we ask here is that does this really raise a point of concern? And this is what we try to answer by doing some quantitative study. So we took up two categories, we had to start with something. So we took up these two categories, but now we have extended it to multiple other categories, and our observations actually fit well in those categories also. So so we took up here backpack and battery, and we crawled the Amazon website and we collected the recommendations as well as the metadata for all the different backpack items and the battery items that are present on the platforms. So around 10,000 plus backpack items are present on the Amazon platform at the time when we crawled. And in the battery category, there were around 5,000 plus items. And the private levels among these 10,000 were only 161 for the backpack category, and for the battery category, it was as low as 17. So with this data, we went on to do some auditing. And how did we launch this audit? So we actually had a formulation of the entire data set in a network or a graph, and we tried to represent the recommendation ecosystem using this graph, which we will refer to as the related item network from now on. So how does this graph look like? So suppose you have certain items like ABC, as I have noted down here, and suppose there are some related items like A has relations to BCD, B has relations to ECF, and D has relations to DEF, which means that when you land up on the page of A, items B, C, D are recommended to you. When you land up on the page of B, items ECF, we construct a directed graph where you have ages directed from ages direct. So the nodes are basically items, and the ages indicate recommendations. So if B is recommending C, then you have a directed age from B to C. So basically the in degree in this graph would indicate how many recommendations a particular item gets from the other different products. Okay, so you have the different products as nodes, and the ages, directed ages, telling you if a particular product is recommending some other product, and the in degree of a particular node would indicate how many recommendations are you receiving on this platform from the other products. Now, yeah, so this is a pictorial explanation of what I just now said. So now we constructed two such networks, one from the data set that we gathered through the organic recommendations, and the other that we gathered through the sponsored recommendations. So the related item network that we constructed from the organic recommendations is what we call the organic range, or O, whereas the sponsored recommendations are those, so the sponsored green is the one which we constructed from the sponsored recommendations and which we call S. So our operationalization of bias here is like, how much does S deviate relative to O? Now, what does this mean? Like, these are two networks, so we cannot, like, directly measure deviations at the network level. So what we do is we extract different statistic from S and O and try to see how the statistic deviate from one another. So how S deviates relative to O. So O is kind of our, like, the basis. So this is organic, so therefore this is basis. So this is something that it should be like, and how far are the sponsored recommendations like the organic recommendations? That is what we question. So, and we evaluate using different metrics. Like here, I'll be talking about only two of them, but I would invite all of you to look into the paper if you're further interested in the other forms of biases that we looked into. So we'll talk about promotion bias and. So what is promotion bias? So it's simply the measure of the in degree. Okay, so here I'm showing you the results for the battery category. So what does this result tell me in short? So if I find out the average in degree of the nodes in the two networks, that is the organic RIN and the sponsored RIN, they are very similar. Okay, but the moment I segregate the products based on whether they are private labels or they are third parties, we start seeing differences. In the organic RIN, like the average in degree of a particular private label product is like roughly 4 times. But what is extremely surprising is that in the sponsored recommendation or in the sponsored related item network, the differences are extremely pronounced, whereas the average degree for the third parties is like 9, the average degree for the private label products is like 520, which is like 10 times, so, or 100 times in fact. So I'm sorry. So the recall that in the whole network there are only 17 private label products in the battery category. So these 17 private label products actually draws, like in the sponsored recommendations, it seems like they draw almost all the recommendations. So this means that whatever product page you land up to, you are going to be recommended some or the other private label product. In fact, more than one. Now, then we went one step forward and we started studying like the standard network science statistic, like in degree distribution. And what we saw is that in the organic network, the in degree distribution has some disparity between the third parties and the private labels. The private labels are slightly larger than the third parties. However, this is like hugely disparate in the sponsored recommendations. So basically, like almost all the recommendations seems like getting routed to this small set of private label products. So next, we also tried to quantify exposure that a product gets on these platforms through this metric called the exposure bias. So what we do, we basically take the two networks, the sponsored RIN and the organic RIN, and we run a random walk. So the random surfer model, and we compute the visit probabilities, like the stationary visit probabilities gives us a distribution of the number of times that a particular random surfer would land up to, like if they start visiting from any node. And these two distributions are like our what we call the exposure distribution. So basically you have one distribution from the organic network and one distribution from the sponsored related item network. And what we do is we try to compute simply the KL divergence between the two. So we try to see that how far are the exposure distributions of the sponsored recommendations compared to the organic recommendations. And what we observe is as follows. So in the sponsored related item network, Amazon private label products actually get a very large exposure compared to any other product. In fact, if you go to the organic related item network, the Duracell is the product that gets the largest exposure. However, the role gets reversed when you look into the sponsored rinse. In the sponsored rinse, actually Duracell gets a much lesser exposure than the Amazon private label products. And in fact, many other very well-known brands are highly underexposed in the sponsored recommendations. So like around, we calculated to get a ballpark number, and what we saw is like around 75% of all the brands are underexposed. So what we observe from here is that Amazon private label products are significantly overexposed in the sponsored recommendations as compared to their organic counterparts. Now, we extended this study to look into something more like nuanced, where rather than looking into the private label products, we started looking into the special merchants who are like at a larger stake, I would say, or I would imagine, because they have to earn their livelihood from this platform. So, and let's see like what happens here in this space. So basically in India, Amazon cannot sell directly its own products. So there are some FDI regulations which prohibits it to do so. So in order to circumvent this, so what Amazon has done is that it has like made joint ventures. It has launched joint ventures with two very big retailers, which are like Cloudtel and Apparel. And these are actually called the special merchants. So they have special relationships with Amazon. So, and these two merchants like have been named so by the Reuters article, like, and from then onward, this phrase special merchants have gained a lot of like traction. So if you look at the product page of at a typical product page of Amazon, you will have a view like this. Now, there are certain nuanced things that are like that can be observed if we look at this page more carefully. So you will see that there is something called a buy box that is highlighted here. So, and there are certain algorithms that are responsible to identify this. So to identify like which product or which seller wins this buy box. So the idea is that there are multiple sellers contending for this position, this buy box position. Okay, and there is an algorithm that internally decides that which among these sellers should be chosen and should be highlighted into the buy box. Remember that all the other offers are hidden on the main product page. Only when you blow up, you get to see them in a separate page, in a completely separate page. So nowadays it comes in a separate tab. So earlier it used to come in a separate page. Nowadays it comes in a separate tab. And there you clearly see the buy box winner separately distinguished from the other sellers. So, and the rest of the sellers are typically sorted by the price plus delivery. So there has been a lot of concerns again around this buy box idea, and there has been a lot of antitrust meetings. Even there is a recent antitrust meeting that is going on around the algorithms that Amazon uses in order to, select the seller who wins the buy box, because that gives the seller a direct advantage, because it has been seen that in most of the cases the customers do not go beyond like the buy box winner. So most of them hardly look into the separate set of offer listing and choose one of them. So typically like a majority of them would go with the buy box, and therefore there is a lot of value in winning the buy box. So we tried to do some audits related to the Amazon buy box itself, and we tried to see like whether there are any conflicts of interest. So if for doing this, we collected again a data set. Typically, we started off with the backpack and the battery category, which we knew pretty well from our earlier study. But then, like now, we have extended it to other examples, like which are around top 100 search queries that are like typically searched on an Amazon platform. So what is the data format? So we collect the data format as what we call a competition. So, and what is a competition? It's a product along with its, okay? So we treat each visit to the product page as a separate competition, okay? Which could have been owned by any one of the competing sellers. Now, competitions could be again broadly classified into two types. One, where it involves the Amazon special merchants, and where it does not involve an Amazon special merchant. Okay, so there are certain competitions where an Amazon special merchant is involved, and there are certain competitions where Amazon special merchants are not involved. So we segregate these two separately. And in a moment, we will see like why we do this. So the first thing that we try to see is like whether there are out of position wins in the buy box. So let us say we have a particular product, okay, and these are the available offers from the different sellers. Okay, so if we look carefully, what would be our like honest take on which among these should win the buy box? Okay, so the Amazon special merchant, that is CloudTel, is shown in a different color. So these are some of the features that you see here: the base price plus the delivery charge in INR, the positive rating, the percentage of positive feedback that this product has got. Okay, so these are some of the indicators of like what could be a possible choice of the buy box winner. So whom do you think that we should put as the winner of the buy box? So there are these 10 offers, and we want to choose one of them. So, okay, one could go with the first one, which has the lowest price plus delivery option among all the others. One could also choose lowest price plus delivery, but along with a much better seller performance, which is like, which has a rating of 4.5 and which is pretty high, like considering the bars that Amazon actually claims to be high on various different blog articles. So, so what should be one? Would it be Global Infotech or would it be Descartes? So when we are set up with this dilemma, let's see what Amazon has to provide, offer us to. What we observe is that out of all the competitions that we collected, the 10th offer actually won the buy box 90% of the times. Okay, so these are competitions where special merchant is involved. So these are the AC ones, the AC or the competitions where special merchants are involved. So out of all the competitions that we had in our data set, like the 10th offer won 90% of the times, and the rest 10% was won by the possibly the best offer. So, and this is not a pathological case. Like we looked into a large number of queries, and we observed that the results are very similar. So if the competitions involve the special merchants, then out of position wins are mostly taken by the special merchants. So all the out of position wins that happens, out of that 91% are by the special merchants. Whereas if we look at the out of position wins for those where special merchants are not present in the competition, it's much more flat. So the distribution is much more uniform, and the distributions are significantly different. So, okay, one can argue that this might happen because the Amazon SMs offer are genuinely better than the third-party sellers. So let's see, like, so we thought, like, let us see, like, whether this is the case. So is it really because of the different, like, so-called good characteristics of the or the good features of the products that are offered by the Amazon special merchants, which makes them win more of the competitions? So in order to do this, we develop different student models. So the student models are built from 3 different types of training data. One, where we only include those competitions where Amazon special merchants are present. The other, where the Amazon special merchants are not present. And then we have where both the Amazon special merchants are present, as well as those where the Amazon special merchants are not present. So we had 3 different training data sets. So now, given the different features like price, delivery time, whether sold by the special merchant, this is specifically in case of AC. In case of ANC, you don't have this because like there is no special merchant there. So only in the AC you will have this special merchant concept, and this feature is 1. So and we try to, like, among several offers, we try to predict which one is going to win the buy box. So, and this is a binary classification that we do, and we use a random forest classifier to do this. We did not go for more fancy models because this itself, as you see on the right hand side, gives us pretty good results, both in terms of precision, recall, as well as accuracy. And a similar approach has been also taken by this paper by Mislav and Wilson in their WW16 article. So we just followed the same student model that they had developed. We just adapted it. So now, then we set up a counterfactual scenario. So, and in this counterfactual scenario, what we like hypothesize is that, like, if I simply switch off the special merchant bit, then also my true positive rate should remain same. That is, the buy box wins should not be guided by the special merchant bit. So even if the special merchant bit is off and the Amazon special merchant offers are really good, then they should come at the top. Okay, so that is what was the hypothesis. So therefore we did not do any change in the training data. For the test data, we had 2 different test sets. One was where we had the original test data, and the other one was the counterfactual test set, where we set the sensitive attribute, that is the SM bit or the special merchant bit, to 0. So basically, the special merchant bit in this test set for the AC data set only. So for ANC, everything was 0. For the AC data set and for the global data set, where you had this special merchant bit on, we switched it off. Okay, so this is our counterfactual setup. So, and once we switched it off, we tried to test these 2 different test these 2 different test sets using our trained models. And what do we see? So what we observe is that there is a fall of 75% in the recall. So the recall earlier was close to 95-96%, and it has dropped to somewhere around 24 or 25% for the AC model. So the moment you switch off the SM bit, the recall actually for the AC competitions drop like drastically. There is a drop in the global model also. However, for the AC model, where it is dominantly where the training was dominantly done with features where the SM bit was on, the moment you don't show this model, the SM bit, all this like test cases actually result in a very poor recall. And note that this particular SM bit feature, the sensitive feature, was not actually one of the significant features. So we actually did significance test using the Shapley method as well as the standard other chi-square methods, and we saw that the significant feature was like coming at the 3rd or positions. So price, delivery, etc. were the top features. However, the moment you switch this off, like the recall drops significantly. So we also tried to do something beyond Amazon. So all this time it was mostly Amazon. In the last 5 minutes, I'll try to wrap up my talk with something that we did for like something that is more make in India. So we wanted to do some similar audits on the Flipkart platform, and we observed that there are also several inconsistencies on the Flipkart platform. So what did we do? So we went with some like a bunch of keywords. Like we collected some around like 100 keywords, and we launched like automatic search with these keywords. And what we saw is that there are some very interesting things that are coming up, that are popping up. So the first thing is that there is a declaration in the search engine result page. So ACRP stands for search engine result page. There is a declaration that there are around 40,000 products on tempered glass. Okay. However, when we proceed forward, what we see is that after 1,000 products, the results stop. So the results from 1,001 to the rest 40,000 is never shown. And this is for like irrespective of any search query that you put on the platform. So you are only able to see the first 1,000. Okay. So that is the first probable inconsistency that we felt. The second thing is that like not all of these 100 search results that you see there are organic. A large number of them are ads. Like there are 11 such ads placed on the first page itself. And like this is what is an ad. So it is a bit difficult to probably see, but this is how a hologram-like shape is what is telling you that this is an ad. So there are 11 ads on the first search engine result page, and then there are 10 ads in the next 24 pages. So that makes like 251 ads out of 100 organic results. In addition, there are also private label products. So there are ads, private label products, and that make up a large part of the search engine pages, especially the initial ones, which are very important. The times it has been found that like customers do not visit like more than 3 pages at a stretch, and these are not pathological cases. So one more very interesting observation that we had is that there is a repetition of the exact same product on all the search pages. For example, if you look at this particular product, this is a Flipkart private label product. Okay, this product actually never appeared as an organic search result in any of the pages. So here I am showing a grid-like structure, and this is how actually Flipkart shows its results. So there are 10 such rows, and in each row there are like 4 items. So 10 rows and 4 columns, which makes 40 items. So each search engine page is a 40 item view, and there are 25 such views. Okay, so that makes 1,000 items. So now, like what we observe for this particular private label product, and this is not a pathological case again, that like this product never appeared as an organic result. It always appeared as a sponsored product or a private label product. Okay, in the first page, it appears as an advertisement in the first search engine page at the position 1, 2. In the next subsequent pages, like it appears also at very strategic positions. At 1, 4, it appears 1 time. At 2, 4, it appears 18 times. And at 3-4, it appears 5 times. So it's the exact same product that is appearing on all the different 25 pages, and also at very strategic locations. So this is something that was very intriguing to us. Like we could not make out like why this is so. Probably so there is some nudge that is there. I mean, and this might have very strong inadvertent consequences to the sellers. And as I said, that this is not limited to, like, we looked into like many other products. I'm showing you some 10 example products here, and we looked at like the top 1,000 results for different search queries for these 10 products, and we observed that in a large number of cases, products which have special relationships with the Flipkart marketplace, they appear on all the 25 pages of the search engine. So like, so this is what like kind of justifies the title of my talk. So the e-commerce platform or the marketplace actually seems to work as Elizabeth Warren once said in her campaign, in her presidential campaign, that it's actually acting both as an umpire as well as a player. So as an umpire, it has control over different algorithmic systems. As a player, it competes with the other third-party products on the platform, with the sellers on the platform, and it has control over like the buy box algorithm, and its offers from the special merchants actually directly compete on the for the buy box wins. And as we have seen, like there are something that seems to be inadvertent that is going on in the selection of the offers that are showcased in the buy box algorithm. So I'll stop here and would be happy to take questions. Thank you very much.
Professor Mukherjee, that was a very nice detective work. So there are some questions, and because of lack of time, I'll just put across just one question: that whether the seller merchant's past performance itself, like whether how many users are actually preferring, or what percentage of users prefer that particular merchant over others, actually play a role in the selection or in the algorithm itself, pushing it to the top.
Yeah, very good question. So as I said, that if you look into this example, so these are some of the past positive average rating that the sellers have got, the percentage of positive feedbacks that the sellers have got, and we included all of these as features in our student models. And what we observe is that for the ACs as well as the ANCs, some of these actually come at the top rank when you rank the features. So which kind of give us some confidence that indeed they have a lot of importance.
Okay. And is there a fair competition law that they are supposed to follow, the e-commerce websites?
Okay, so this is debatable. So like all the antitrust subcommittee meetings, if we follow, like there is this point that you cannot be, the umpire as well as the player at the same time, because you have in that way, like you have a lot of control over different things which the other sellers do not have, and therefore there is of course a point of unfairness. So in addition, there are a few other things which I did not cover due to the constraints on time. So you might always argue that, okay, sponsored recommendations are supposed to be different from organic recommendations. So that's a very natural thing. But the question is like, what is the tolerable difference? So if you look carefully, so there was a survey done among US customers, like where they surveyed like around 2,000 customers and asked them like whether they are able to differentiate between sponsored recommendations and organic recommendations. And like more than half of the participants said that they never realized that these two things are different. So that means what is happening is that many of them are unknowingly landing up onto sponsored recommendation pages, and recall that this actually affects their viewership, and this indirectly has a delayed impact on the organic recommendations. So there has to be some like, that needs to be made in order to have a tolerable limit as to how much the sponsored recommendations should be different from the organic recommendations. The second important point is there is also an economic implication here. So whenever Amazon actually puts up ad spaces for different sellers, so the sellers have to pay additional money in order to put up their items on the sponsored list. So now Amazon seems to be blocking some space for itself. Now this ad space that Amazon has blocked for itself, actually could have earned some profit to Amazon if that was released to other sellers. So and this means that an amount of ad space is being used by the in-house the in-house sellers. So this indirectly could impact the price of the rest of the ad space. So basically there might be an internal calculation going on inside Amazon. So this is just again like an open thought, and this might again be debatable, but one thing that is for sure is that the algorithms for this pricing etc are again controlled by the platform itself, and therefore like in order to reserve the ad space, now the sellers might need to pay more to Amazon because a part of the ad space has been like made inclusive for Amazon itself.
Thank
so
you.
there
Thank
are
you,
economic implications also.
Thank you, Professor Mukherjee. Over to you, Anvit.
Thank you so much, Professor. I believe that was definitely a talk which everybody enjoyed, because all of us, irrespective of which background we're from, we all use e-commerce platforms. So definitely some things which we learned, and thank you again for sharing your time, sir. If you can stop sharing your screen, sir, for a moment. Thank you. Once again, we'd like to thank Professor Animesh Mukherjee for sparing the time, and thanks again for the knowledgeable talks.